Howdy, let's look at rational expressions. Section 8.4. Rational means, like a rational number, is a number that can be written as a fraction. So rational means fraction-esque of some way. An expression means the algebraic expressions we're going to use. So this basically means algebra fractions. Woo! Okay, let's look at an example. Let's look at 48 over 42. And this is not a rational expression. This is just a fraction. Okay, now when you cancel out stuff in a fraction, they have to be factors separated by multiplication. That's the key, factors separated by multiplication. So I can't just cross off the 4 and the 4 here because 4 and 8 are not separated by multiplication. Neither are the 4 and the 2. This means 4 10s and 2 1s, and you add those together. It's not, if I put a multiplication dot there, I could do that, but I can't. Okay, so just like in an expression, if you see an x in the numerator and an x in the denominator, you can't just cancel them out unless they're separated by multiplication. So what we would do, and we usually just reduce this in our heads, but in the numerator, I would say what this is 6 times 8, and the denominator, that is 6 times 7. And now that I have factors separated by multiplication, I'm going to say that about 1,000,000 times. Now that I have factors separated by multiplication, I can cancel something out. So as a good friend always told me, pa-choo, pa-choo, and that gives me 8/7. Okay, so we're going to use the same idea when we are working with fractions. Okay, so let me look at another one here. Let's look at x to the 5th over x to the 8th. Normally, when we have something like this, we have always just subtracted the exponents. So 5 minus 8 gave us a -3, and that became 1 over x to the 3rd. And after a while, we would just even skip this middle step. We would say, well, 5 minus 8 is -3, and that puts it in the denominator. Or we could think about this the same way. And this really is much ado about nothing. Normally, we're just going to do this quick step. But I want to show you this works here as well. So let's write x to the 8th power as a factor that'll cancel that out. So it'll be x to the 5th times x to the 3rd. And then the x to the 5ths will cancel out, giving me 1 over x to the 3rd. So you can cancel stuff out as long as they are factors separated by multiplication. Factors separated by multiplication. Goodness. Okay, let's try a little bit of a different example here. Let's try an actual algebra fraction. Let's try x squared plus 2x plus 1 over x squared minus 1. Okay, well, what's going to happen here? The first thing I'll need to do is factor stuff out because I can't just cancel out the x squared. They are not factors separated by multiplication. It's separated by addition and subtraction. So in the numerator here, that factors 2x plus 1 and x plus 1. And the denominator is difference of two squares, x plus 1, x minus 1. And now I have factors separated by multiplication, so I can cancel stuff out. X plus 1 and x plus 1. This gives me my final answer of x plus 1 over x minus 1. Now, a number of these problems will start to say, state any restrictions on the domain of the function, or any restrictions on the variables, or something like that. And what you need to do is just keep in mind the denominator can't be 0. So what I do is I look back at the step before I reduce at the denominator and set each of those factors equal to 0. So what plus 1 will give me 0? -1. And what minus 1 will give me 0? 1. So x can't be 1 or -1. Now, for my final answer, I can tell that x can't be 1, but I can't tell that x can't be -1 as well. I have to look back here to see that x can't be -1. So even though that canceled out in the step, for me to say that these two things mean the same thing, I need to include those restrictions. This is not the same as this, unless I put that stuff there. These are not the same at -1, because -1 doesn't work in this problem, and -1 does work in this problem. It's an incredibly, infinitely small difference between the two. We need to note it if they tell us to do so. I guess I forgot. If I go up here, I can do the same thing here. What value will make this denominator 0? Well, x can't be 0. Sorry, I forgot to do that. On a final note, I just want to note a couple fraction operations. When you multiply fractions, you multiply straight across. When you divide, you copy, change, flip. Copy the first fraction, change division to multiplication, take the reciprocal of the second fraction. And that's it for your notes for section 8.4.